All right, welcome back. Um, Page 197 of your workbook, we're going to get into this next section, determining the equations of trigonometric functions. All right, so here we go with this next section. This starts off with some notes about determining your equation. This starts off with talking about your sine value. This starts off with, and your cosine value, your start points. And so we have this right here is your start point for your sine wave. If we have a positive sine graph, here's your start point, is where it crosses your median line going uphill. Whereas your cosine graph, your start point for your cosine wave, if it's a positive cosine wave, your start point is at this maximum. And that's a critical piece of what we're going to be doing in here. Some steps. First, find and draw your median line. So that is your D value. So this median line is halfway up this wave, halfway between your maximum and minimum. We're going to come up with this formula for your D value. It's going to be your average of your maximum and minimum values. And that makes sense. If we're trying to find where this is, where the height of this is, it's halfway between this height and this height. How do you find halfway between those two heights? You add them together and divide it by 2. You're just finding the average of them. Second, your amplitude. Amplitude is your A value. Technically, amplitude is absolute value of your A value. Because if A is negative, your amplitude is still just a positive amount. It's a measure of how tall half the height of the wave is. So the distance between your median and your maximum, or your median and your minimum, is your amplitude. That means if we're going to start to make some formulas for this, max minus median, or median minus minimum. That always works. Third, find the period. How long does it take to do one full cycle of this wave? If you measure from a start point to the next start point of sine, that's one full cycle. Say that next start point was off our graph, and really we could only measure this. That's the start point to halfway through this wave. That's going to be half of your period. And so you could just measure this distance and multiply it by 2. Fourth, find your B value using the period. Finding your B value by using your period. We've talked about this before, that period is equal to 2 pi over B. That's on your formula sheet. That also means if I algebra that around, B is equal to 2 pi divided by period. So it works both ways, if we solve for B or if we solve for period. So that kind of ends up being a handy tool that we will often be using. And then fifth point. This one is kind of trickier. It says finding your C value, counting from the y-axis. This just has to do with this idea of start point. A cosine graph begins at the maximum, it goes down. A sine graph begins on your median, and it goes up. So here's your start point for cosine. That will be what C is. This has been a horizontal translation. It looks like 3 pi halves to the right. So as a cosine graph, this would be cosine of pi minus 3 pi halves. Not paying attention to all the rest of those pieces. As a sine graph, not paying attention to A or B or D, this would be shifted pi halves. So theta minus pi halves. Now, if we have a reflected cosine, that means we're going to be looking at calling our equation y is equal to negative cosine. Well, a reflected cosine If we have a reflected cosine, it's going to have a start point at the minimum. If we have a reflected sine graph, y equals negative sine. If we have a reflected sine, the start point is still on the median, but it's when it's going downhill. And you'll see how all of this comes into play here. One last reminder that we need to be careful about. We need to make sure that this is in factored form, that b has to be factored away from x. Either x or theta, that's got to be by itself in this binomial. If we don't have a c value, it's not going to matter. But if we've got this c value that's added or subtracted, we have to make sure that this coefficient on x is common factored away from here. Something that's going to come in handy is formulas that are not on your formula sheet. You don't have to use them, but if you find them useful, then you can use this. I find it easiest to remember what D is. D is your median, which ends up being, if we've got a maximum and a minimum, our median is halfway in between those. And I'm going to remember that because I'm going to average those. Max plus min divided by 2. Whereas A is going to be max minus minimum divided by 2. Right? If I take my maximum height and I subtract my minimum height, that's going to be this. The difference is going to be the whole height of the wave. When I divide it by 2, now that's just half of the height of the wave. So there's a formula for A. Also formulas for A, max minus median, just this distance here, or also median minus minimum is this distance here, of course. Period is 2 pi over b, b is 2 pi over period, and let's move on. Here we go. So given this graph, how do we find an equation for this? I actually would rather not start with amplitude. I kind of like to start with our median because we can see that we have a maximum height of 2, and we can see we have a minimum height of -4. This is another word for this. This is sometimes called vertical displacement. And it's your median line. And if it's the average of those two, it's going to be your max plus your minimum divided by 2. 2 plus -4 over 2 ends up being -2 over 2 is -1, which is actually kind of obvious. Do you need to do all that algebraic work to find it? Well, not necessarily, but it's good to, especially if it's kind of obvious like this one, from -4 to 2, it's kind of clear that -1 is right in the middle of that. So there's your median line. I like to start with that because my amplitude is now going to be how much up from our median are we? So our max minus our median is 2 minus -1. Careful of subtracting negatives because this is 3. What that means in our equation is A is going to be 3. Technically, let's call it absolute A is going to be 3. This vertical displacement, that told us that D was going to be -1. All right, period. Period is a little trickier. A and D are maybe a little more straightforward. Period. We have this start point here. Well, this would be the start point for negative sign. If we're wanting regular sign, let's have our start point here. Okay, let me back that up. Let's say that I'm going to call this a regular sign equation. There's my start point. Here's my next start point. That's one full cycle. How far is this? So if I'm needing to find how far this is, Okay, so now we need to figure out this scale and what's going on with this grid. If I'm counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like these grids are each pi over 12. And to go from here to here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like we have 12 grids in between those start points. That means our period is pi. That means b is equal to 2 pi over period, so 2 pi over pi, which means b is 2. Now, surprisingly, we have enough to come up with an equation. If I want a sine equation, what do I know? Y is equal to a is 3. My horizontal stretch was a factor of a half. My b value was 2. I'm going to fill this part in just a second here. My vertical displacement, my median, is -1. All of these equations are going to kind of look like that. They're going to have an a of 3, a b of 2, and a d of -1. The only thing that's going to different is going to be the sign, the positive or negative on your a, and what happens in these brackets. The c value is going to be different. And so when we do this, what do we have here? Where's the start point for sine? We usually take the smallest or the least phase shift. Technically, both of these would be correct, whether we use this point here or whether we use this point for here. Those are both start point for sine. We usually take the least, the smallest one. And so that would be this one where we are shifting to the left by 1, 2, 3, 4 pi twelfths. And 4 pi twelfths, if we reduce, this is theta plus 4 pi twelfths is pi over 3. Our cosine equation is going to look very similar. Amplitude is still 3. This is cosine of b value is still 2. The only thing that's going to change is what's in these brackets. That's still -1. Where's my start point for cosine? My start point for cos is at the maximum. And that appears to be at pi over 12. So theta, it's to the left, so it's plus pi over 12. Sine equation with a reflection in the x-axis. What that's getting at is this, that we want -3 sine 2 bracket -1. So everything's really the same except the sign on A. A is going to be -3. What do we have for phase shift? So this is negative sign, which means it's where it crosses the median line, but going downhill. So this is no longer the start point. If we're talking about negative sign, our start point is right here. My start point is that dot that's on this graph, and that shifted 2/12 of pi to the right. So this is theta minus pi 6. And then the last one, the cosine, -3 cos 2, leave some space in the brackets, -1. And now we need to know our phase shift for negative cos. Negative cos. Positive cos started at the maximum. Negative cos starts at the minimum. And this seems to be 1, 2, 3, 4, 5 pi twelfths to the right. So theta minus 5 pi over 12. Whew. The last part says, let's verify one of these equations with a given point. So if we want to verify, and where's that point? It looks to be at pi 6. So 2 pi 12ths, which is pi 6, comma, -1. Well, we could take any of these equations. Let's just take the first one. If we take y is equal to 3 sine of 2 pi 6. Actually, let's leave it as our formula to start with. The sine of 2 theta plus pi thirds minus 1. When we do a verify, and we're going to start to see this when we do trig equations, we need to break this apart into the left side and the right side. The left side is just y, and it's equal to -1. The right side of this equation is a little more complicated. Right side of this equation is this: 3 sine 2 theta plus pi thirds minus 1. If I'm verifying it at pi 6, then x, or theta in this case, is pi 6. So 3 sine 2 of pi 6 plus pi thirds minus 1. And we're going to have to algebra this. Pi 6 plus pi thirds is pi 6 plus 2 pi 6. If you're okay with that, I skipped half of the step there. Pi 6, and I'm adding 2 pi 6, right? If I convert pi thirds, that's 3 pi 6. I simplify this, so 3 times sine. 3 pi over 6 is pi over 2 times 2 is sine of pi. That's what this all is going to melt down to. Now we have to think about our unit circle. Pi is here. What's our sine value here? So our sine value here, the sine is the height. So this is equal to 3 times 0 minus 1, which is equal to -1. At this point, our left side is -1, our right side is -1, therefore, left side equals right side. And we have verified that it is true for that point. Next one. We appear to have a maximum of 2, a minimum of -4. That tells me that halfway between 2 and -4, if I average those, that's -1 again. So D is equal to -1. Our amplitude is going to be your maximum minus your median height, and we have a maximum height of 2, medium height of -1. 2 minus -1 is an amplitude of 3. That's pretty clear. It's pretty obvious. That's amplitude is of 3. We have period. This is trickier now. We don't really have, we barely have a, well, I guess we have about a full cycle showing here. We do know that this, we have this maximum that appears to be, this is tricky. 1, 2, 3, 4, 5, 6. So again, we have a scale of pi 12ths. This is 8 pi 12ths, which if we simplify that, that is 8 pi 12ths is 2 pi thirds over 2. It looks like we have a minimum way back here. And our minimum happens at, there's -12, 13, 14, 15, 16, -16 pi 12ths, which is -4 pi thirds. over -4. Now the distance between those, is that one full period? No, that's just the distance between your minimum and your maximum. So that's half of a period. So a period ends up being, we could say that it's the difference between those 2 points, so 2 pi thirds minus -4 pi thirds. If I subtract them, that's going to give me that horizontal distance, but I'm going to need to multiply it by 2. I get 6 pi thirds in the brackets there, times 2 is 12 pi thirds, altogether is 4 pi. There's lots of different ways of counting that out. But subtracting those 2 x coordinates, that will give you half of the period. So the period is 4 pi. What does that tell you that b is? B is equal to 2 pi over period. So b is equal to 1/2. That makes sense. That's had a horizontal stretch factor 2. All of that said, sine, where does it cross the median? Going uphill. There's your sine start point. So y is equal to 3 sine 1/2 theta. What do we have? We're going to the left by 1, 2, 3, 4 pi twelfths. So again, theta plus pi thirds. Minus 1. Our cosine requires that maximum. Y is equal to 3 sine half, and it's been shifted to the right by 2 pi thirds. So there's my cosine equation. Oops, oops, oops. Cosine, please. Sorry about that. What the heck? All right. Negative sine equation with a reflection in the y-axis. Y is equal to -3 sine of 1/2. Let's go check this out. Where does sine cross the median line but going downhill? That's going to be this one here. It's 12, 16, 17, 18 pi twelfths. 18 pi over 12 is 3 pi over 2 to the right. And my last one, y is equal to -3 cosine 1/2. And the negative cosine starts at the minimum. Your start point for negative cos is way over there, x plus 4 pi thirds. Verify one of these with the given point. The given point on this graph was this one up here. So that was at 2 pi thirds. So if I take any of these equations, doesn't really matter which one, we have 2 pi thirds, comma 2. We have y is equal to 3 sine half theta plus pi thirds minus 1. The left side of this equation is just y, and y will equal to the right side of this equation. A little bit of heavier lifting going on. Ends up being 3 sine of 1/2 theta plus pi thirds minus 1. That will be equal to 3 sine of 1/2 times, what do we have? We have 2 pi thirds plus pi thirds in those brackets. 2 pi thirds plus 1 pi third is 3 pi thirds. So this is just equal to 3 sine multiplied by 1/2. It's pi over 2. Sine of pi over 2. Where is sine pi over 2? Pi over 2 is 90 degrees. What's the sine value there? That is the y value, and that's positive 1. So 3 times 1 minus 1 is equal to 2. Therefore, yay! Left side equals right side. That's it. Okay. A couple more. Determine 4 possible equations for each of the following. Sine, reflected sine, cosine, reflected cos. Verify one of the equations for the given point. All right. So let's start to streamline this. We have a median at 1. It goes up by 2 and it goes down by 2, up to a maximum of 3 and a minimum of -1. Therefore, we can infer that D is equal to 1, A is equal to 2. We appear to have one period, one full cycle takes 2 pi. So therefore, B is equal to 1. There's been no stretch. B is equal to 2 pi over a period, so 2 pi over 2 pi, so B equals 1. Let's do this one as, so therefore this ends up being y is equal to 2 sine, B is just 1, so this ends up being theta. What do we have for a phase shift? It hasn't been shifted. That start point is right on the y-axis, so we can just call it sine theta. We don't even need brackets on this. And then it's plus 1. So there's my equation. Come on, let's get rid of that 0. Okay, next one. We could also call it cos. So 2 cosine, but now we've got a phase shift on here. So now we only need brackets around this. B is still just 1, so that's not going to be relevant. Start point for cos is here, up at the maximum. And that happens to be at pi over 2, right? So this is theta minus pi halves because it's to the right. Y is also equal to -2 sine. What do we have? So if we have our negative sign, that means we're across the median line, but going downhill. There's your start point for negative sign, also over here, but we take the, well, they're both phase shifted either pi to the right or pi to the left. So let's take the one that's to the right, please. Let's call this theta minus pi plus 1. And our last one ends up being y equals -2 cos. Where do we have a start point for negative cosine? At the minimum. And so that's theta plus pi over 2 plus 1. Next one. So as we get through this, these become a little, starts to make a little bit more sense. D equals -2 because A is equal to 1. We have one full cycle. Here's a minimum. Here's the next minimum. So B is equal to 2 pi over period. 2 pi over pi. So B is 2. That makes sense. It's had a horizontal stretch factor of a half. Let's start to put this together. Y is equal to sine 2. We need our start point for sine. That's going to be right here. If this is pi to do one full cycle, that means this maximum is at pi over 2. That means this median line is at pi over 4, right? Your maximum will be halfway in between two minimums. Your median will be halfway in between a max and a minimum. And so this ends up being sine of 2 theta minus pi halves. Sorry, pi quarters. Sure we did. Pi quarters. And then median minus 2. Cos is just 1. So cosine of, what do we have for cos? Where do we have a start point? Start point for cosine is at a maximum. So theta minus pi over 2. Minus pi over 2. And then if I have my negative sign, what does negative sign look like? Negative sign, my start point for negative sign is right there, halfway up the wave, but going downhill. So this ends up being theta plus pi quarters. And my last one, y equals negative cos of 2. And what do we have? We have negative cosine. The start point for negative cos happens at the minimum, and that's on the y-axis. So there's no phase shift. So this is negative cosine 2 theta minus 2. Don't need brackets, no phase shift. That's it. Hey, maybe hit pause here for a second. I'd like you to try this one. You go through it, and I'll catch up to you in a second. Just hit pause. All right, here we go. So what do we have going on here? We have a maximum of 2, a minimum of negative 4. Tells me my median is halfway in between those. V equals negative 1, A equals 3. We have a maximum at 0, 2. We have a minimum at 2 pi, negative 4. That tells me this is 2 pi. Is that the period? No, it's just half of the cycle. And so therefore, period is equal to 4 pi. B is equal to 2 pi over period, so 2 pi over 4 pi. B is equal to 1/2. That makes sense. It's a horizontal stretch factor of 2. All of that put together, y is equal to 3 sine 1/2, leave some space in the brackets, minus 1. Where's our start point? Start point seems to be right there for sine at negative pi. So theta pi to the left. Y is equal to 3 cos half. All of this is the same. What's different is just the stuff for the phase shift. Cosine starts at a maximum, so no phase shift for this. So this is just 3 cos half theta minus 1. Negative sign. Negative sign means our start point is where it crossed the median line, but going downhill. So here's our start point for negative sign. So this is theta plus pi. Sorry, liar. Theta minus pi, because it's pi to the right. And my last one, y equals negative 3 cos half. And where's my start point for negative cosine? That's the minimum. So it's going to happen here, or it's going to happen here. They're both at 2 pi, to the left or to the right. We should probably take the positive one, the one that's gone to the right. So theta minus 2 pi. The sinusoidal function has a maximum of pi 6, 2. Its next consecutive minimum at 3 pi 6, negative 4. So determine, this isn't written here, but I will, let's fill this in. Determine Well, we can do all four. Yep, let's just do all four again. That's what we're doing on this page. Never mind. Okay, so to do all four, so same thing, we just don't have a graph for this. But we have a maximum at pi 6 comma 2. And we have its next consecutive minimum is at 3 pi 6 comma negative 4. So if I tried to sketch this out, I've got pi 6 comma 2, and I've got 3 pi 6, 1, 2, 3 pi 6 comma negative 4. So just by sketching this out, pi 6 comma 2 and 3 pi 6 comma negative 4, that's probably why this is given to us without that fraction is reduced, just to realize that they're all just counting pi 6. And if they're counting pi 6, and we have a maximum here at pi 6 comma 2, and a minimum at 3 pi 6 comma negative 4, what's our median height between those two? Between a height of 2 and a height of negative 4, our median height is at, well, again, where is it going to cross that median? Well, halfway in between pi over 6 and 3 pi over 6, which is 2 pi over 6. Which means it's going to kind of look like this. Which means every pi over 6 we have another either a maximum or a median line intercept, which means 0 comma negative 1 is your y-intercept. So what can we tell about this? We can tell that d is equal to negative 1. We can tell that a is equal to 3 again. We can tell that b, what do we have for period? This distance from maximum to minimum is going to be half the period. Let's look at that first. Period is going to be equal to 2 times the difference between those 2 points. 3 pi 6 minus 1 pi 6. It's 2 pi 6 times 2 is 4 pi 6. It's 2 pi thirds. Therefore, b is equal to 2 pi divided by this period, which is 2 pi thirds. So b is equal to 3. Kind of makes sense. If my period is 2 pi thirds, it has had a horizontal stretch factor of a third. Okay, so b is equal to 3. Therefore, what do we have? We've got y is equal to 3 sine b is 3, d is negative 1. Where's my start point for positive sine? Start point for positive sine, whereas it crosses the median going uphill. So 3 sine 3 theta minus 1. For cos, where do we have a maximum is your start point for cosine? That's at 2 pi 6, or pi thirds. So theta minus pi thirds. If we have negative 3 sine, we have a negative sine equation. That starts at the median, that's going downhill. We're across the median line, going down. So this ends up being theta minus, it's shifted to the right by 2 pi 6. Sorry, 2 pi 6, which is pi thirds. Let's back that up a second. Oh, maybe you caught this mistake I made here. Okay. Theta is for cosine the maximum. That point happened at pi 6, right? So theta minus pi 6. And this one, theta minus pi thirds for negative sine. And our last one is y is equal to negative 3 cos 3. And where we have a start point for negative cosine happens at a minimum, and that happens at 3 pi 6, which is beta minus pi over 2. All right. And that, ladies and gentlemen, is it. Lots going on in this section. There's a ton of work in here, so make sure you practice these and all will be good. Thanks so much.